Okay, so now we're going to use it like the second page to continue our discussion of like the definitions that we need to know in order to, start, actually like getting at what linear algebra is, which, is basically like systems of linear equations. It is at the heart of linear algebra. So that's why we're going through these definitions. Okay, so another definition that we need to know is whether or not a system is consistent or not. Okay, so like we can say linear algebra definitions continued. So whether or not a system is considered a linear system of equations is considered to be consistent if it has at least one solution. Okay, so, and when I say at least one solution, I mean either one solution, or you might expect 2 solutions, 3 solutions, 4 solutions, but no, it's actually one solution or an infinite number of solutions. Infinite number of solutions, because there is nothing in between, and we'll see through like analyzing these graphs of like lines in just a second. Okay, so it's consistent if it has one solution or an infinite number of solutions, so at least one solution, so it's not like no solutions, and it's inconsistent if it's no solutions. Okay, so a system of linear equations either has one solution, an infinite number of solutions, or no solutions. Okay, so why is that? Well, you might remember like what it means to graph 2 lines of different equations, right? So you might remember that if you have like, I'm going to show you 3 graphs. Okay, and we'll take a look at it, and it'll be clear as to why this is the case. Okay, and when we're plotting lines, we are only using 2 variables, right? We are using x and y, right? There's no way to plot something. I mean, there's a way to plot something if there's like 3 variables, right? You can use like x, y, z plane, but if it has like 100 variables, or like even like 6 variables, how are you gonna like plot it? You can't. So that's why it's that's why I'm using an equation of a line, right? So if you have a line of an equation that looks like this, right? And if you have another line whose equation looks like that, okay? And you see where they intersect. So you find a y value where you find an x and y value where if you plug it into that equation, each equation, if you consider this a system, if you plug in the value x naught and y naught into the system, it's true, right? It's true. It gets you, this x value gets you this y value. This collection of this x and y get you the same point, right? It makes the system true, okay? So that's why when you have one point of intersection of 2 lines, you have one solution. Okay, so this is what it looks like when there's one solution. When you want to see no no solutions, right? So when it's inconsistent, then you can have a line that looks like this. But you have another line that looks like this. Not like that, but like that. Okay, so these are parallel lines. So these are never going to meet. So no x and y value so that you can substitute back into the system will get you the same value, the same constants that you set it equal to in the equation, right? So a1 x1 plus a2 x2 plus an xn equals b, right? So those b's, those constants that you set that collection of equations equal to, they can be different constants in the same equation, right? That's what determines the exact point. So if it's parallel, it's never going to be true. That no matter what values you put into the equations, it's never going to be true. They're never going to be true. So it's parallel, so that's why it's no solutions. Okay? And the last one is infinite number of solutions. You probably guessed this, but it's actually going to be, not but like you're right, it's actually going to be like the same line. Okay? So an infinite number of solutions. So no matter what values, whether it's this xy value, this is a solution, this is a solution, this is a solution, this xy is a solution, this xy is a solution, this xy is a solution. So if you plug it in to each of the equations in this collection of two equations, then you are going to have the same solution. You're going to have the same value. I mean, it's going to be true. Okay, so that's why a system of linear equations either has no solutions, exactly one solution, or infinitely many. Okay, so in our next video, we're going to take a look at how matrices play a role and how we can actually represent systems of linear equations using matrices. But for now, I think this is like a good review, hopefully, of what you've learned already, or maybe it's maybe some of the material is new, but this is sort of the groundwork that we need to lay in order to get started with the heart of linear algebra. Okay, so I'll see you guys in my next video. I hope you learned something new, and until then, take care.